Yes, friends, welcome back. This is Dr. Biju Vasdevan. Uh, in this first part of this video for week 13, we will discuss simplest method for the course Mathematics for Management 1, Math 113. So we have seen what is a linear programming problem and how to solve a linear programming problem by graphical method in the previous video, isn't it? Here we are going to solve a similar linear programming problem. See, that has an objective function, constraints, and non-negative restriction. Isn't it? A linear problem that has all these parts will be solved by a different method called a simplest method. Okay, what is the difference between the first question? What is the difference between graphical and simplest method? In the case of graphical method, only problems involving two variables can be addressed because we deal with a graph of two axes, x and y. But in the case of simplest method, we can solve a problem of n variables. If more than two variables, 3, 4, 5 is possible to solve. It doesn't matter how many constraints are there, right? So let us discuss how to solve this problem first. Let us start the solution here. Then first example for this week is given here. Okay, what is the first step? First step is to write the given simplest method in its standard form. We will write it in standard form. What do you mean by standard form of a simplest method? We write every constraint. This is constraint 1, constraint 2, inequality. We will convert this inequalities into equalities. See what is happening here. 2x1 is not assuming. In the case of graphical method, we have assumed inequality into equality and then drawn the straight lines, isn't it? But here, in this case, the inequality will be converted into equality by adding some variable to the left side of this inequality. You see, roughly, here, if 4 is less than 8, how to make them equal? Add something to the left, isn't it? We call x, if we add x to the left, it will be equal, and then we can find the value of x. So when you add some variable to the left side of the inequality, the less than or inequality will be converted into equality. If there is greater than or inequality, we are supposed to subtract that. That is a different case, right? So when we add some variable here, these variables that are added to the left side of the constraints to make the less than inequality into equality is called a slack variable. These variables are called slack variables. S1 will address. Write the second constraint, 2x1, 3x2, and now another variable. This is s1, this is s2, obviously is equal to 12. And now we will write the objective function. See, I have written only constraints. Now we are writing objective function, which is maximize z. Write all the way. There are now four variables, x1, x2, s1 and s2. So the coefficient of x1 is 1 here, x1 plus 2x2 is given to you, and 0 times s1, 0 times s2. Now it addresses all the four variables in the objective function. 2x1, x1 plus 2x2 has been given to you. You are adding 0s1, 0s2 without affecting the originality of z, isn't it? Because we need these newly introduced variable in the objective function. That's why we added its coefficient as 0. Fine. Now finally we will write non-negative restriction. All the values of x1, x2, s1, s2 should be greater than or equal to 0. These s1 and s2 are called slack variable, or you can call dummy variable otherwise, isn't it? Slack variable because it is added to the left hand side. Okay, slack variables. Now we got this standard form of a linear programming problem. Now from this standard form, we are going to write a new table, which is the first step of the simplest method is to write the standard form, and then we are going to the tabular form. We are writing now first simplex table. We should write this table first, and you are supposed to collect all this information. We will write b or I try to use the notations given in the textbook of your course. br x1 x2 s1 s2. See, br I will give you term by term. x1 x2 s1 s2, you know what are they? These four terms are the variables involved in the problem. There are four variables now, isn't it? Go back. So x1 x2 s1 s2, there are four variables everywhere in every objective function and the constraint. So these four are the variables x1 x2 s1 s2. What is r? R is resources, otherwise the right hand side of the previous problem. See, right hand side, what is it? 12, 812. Fine. Actually, theoretically, it is called resources for the linear programming problem. So we will write this, we will fill this column by using the right hand side 8 and 12. And now fill this coefficients from this constraints. Use this constraints. Take the column of x1, the x1 column. See, this is x1, this is x1. X1 column has 2 and 2. We will fill the x1 column by using the values of x1, coefficients of x1 from the body matrix. See, from the constraints. Now x2, the coefficient of x1 and the x2 in the first equation is 1, the second equation is 3. So 1 and 3. This column will be filled by the x2 variable. Now s1 and s2, you go back. There is s1 in the first equation, but there is no s1 in the second equation. So 1 is the coefficient here, 0 is the coefficient in the second row, isn't it? So this is 1 and 0. Back, because if you write this constraint properly, it will be 2x1 1x2 1s1 0 s2 is 0, isn't it? This is the actual equation. There is no s2, 0 s2. Second equation, 2x1 3x2 0 s1 1 s2 is equal to, this is 8 and this is 12. If you write them, okay, it will be the original form. So now x1 column will be filled by the coefficients of x1, x2 column will be filled by the coefficients of x2, s1 column will be filled by the coefficients of s1, s2 column will be filled by the coefficients of s2. What are they? Go back. 0 1. See, when you go back to the matrix, it will be like an identity matrix. S1 s2, the new variable, the newly introduced variables will get you an identity matrix form, isn't it? Check that should be there in the beginning. And here that's the end of the constraints. Now the column b is b standing for basic variables. Basic variables our solution variables. At the end, your solution will appear in these two boxes. R is the right answer. Here the variables will come. Initially, the solution variables are dummy variables s1 s2. Basic variables are the slack variables. So we fill the column by s1 s2 and R right hand side. So some textbooks R will be here at the end of this one. Maybe in your textbook R will be end of this column, may be in the end, but ignore it. Anywhere you can use it. Fine. Now we have somewhat completed this table, and one more column, one more row should be written. What is it? Is z. Here we write z value. Z is objective function. We fill this. There is nothing. There is this row should be kept empty. This box. Z value, go back to objective function. Z value, z coefficient of x1 is 1, coefficient of x2 is 2, coefficient of s1 is 0, s2 is 0. All these coefficients should be written against those variables in negative sign. That's what we are going to do. X1 coefficient, so I write here z one more time. Z is x1 plus 2x2 plus 0 s1 0 z 0 s2, isn't it? So these two columns s1 and s2 will get zeros. X1 and x2 will be 1 and 2, but we write in opposite sign. This is what you have to do first. One more time, go back to this problem, write the given constraints in a standard form, make it equal by adding a dummy variable to the left side, call the dummy variable as slack variable, and now in the initial stage these dummy variables are our basic variables will be used in the first column, right? And then just collect the coefficients and fill the table. R will be filled by the right hand side elements, and then x1 column, x2 column, x1 column, x2 column will be filled by the values of this one, and the last row will be filled by the opposite values of coefficients of z. That is it. Now let's go back here. Now if there is a negative sign here in the z row, these are called indicators. If there is a negative sign, we have to proceed the problem. If there is no negative sign in the z row, if there is no negative sign in the z row, the problem comes to an end, isn't it? So we will continue this process until we get all non-negative values for z row indicators. So here, since there are some negative values, we are supposed to take the most negative value. Most negative values do a different column. Now out of these two negative values, this is the most negative, isn't it? We are not talking about maximum value or minimum value. Most negative. If I write -3, -8, -10, the most negative is -10. Just remember that. So this is what we are going to do. Okay. So we take the most negative, and this column is called another important column, and this variable x2 plays a good role in this basic collection B. In these two places, x2 will come in the next table. In the next table, we are going to use this variable x2 somewhere instead of s1 or s2. One of them will be moving out from here and from these positions, and x2 will come back to this position, come and join this club, this solution club, right? But the title variable will remain same. We will not remove x2 from here. x1, x2, s1, s2 will be remaining the title, but it will already s1, s2 are there in the title, but still s1, s2 appear here. So x1, x2 out of any variable, either sometimes maybe x1, sometimes s1 will again come, depending upon the choice of most negative. So here in this case the most negative is -2, and the corresponding variable is x2. So x2 is the entering variable. We call it entering variable column, or you can call pivot column, or you can call key column, isn't it? There are different words for them: entering variable column, pivot column, or key column, isn't it? Fine. This column is now an important column for us. Okay, let's find one row which is important. That's called here. I'm going to erase this, is it? I take this and erase this part, is it, from here. We don't want is it here. Okay, fine. One more term I am going to add this table. If there is a negative sign z, we take the most negative and take identify one variable as entering variable, which is x2 in this case. Now there is a column for ratio. The formula for the ratio in this table, for every table we have to rewrite it, isn't it? It is r over the entering variable x2, entering variable column x2, and the elements of x2 should be greater than or equal to 0. Greater than 0, strictly greater than 0. It means you are going to find r divided by r. The column r is given here, r divided by x2. But if there is any negative value or 0 in the column of x2, we will not find ratio, we will dash. If this is -1, I will not find ratio. If this is 0, I will not find ratio, right? That is it. Okay. Now r is 8, x2 is 1, 8 over 1 is 8. And 12, second row, 12 over 3. 12 over 3. See, both the values of x2 are, there is nothing for third row. For both the values of, so you can write here 0. This, don't leave this empty, make it 0. this element 0. So there will be a complete matrix now. 12 over 3, which is 4. Now we got two different ratios. One is 8, another one is 4. And we are supposed to choose the minimum value of the ratios. So minimum value of the ratio will give you the leaving variable. Leaving variable. Leaving variable now s2. What is the meaning? This row is called, again there are three different names just like column. Leaving variable row, or we can call pivot pivot row, or you can call key row or leading column, or you can give different names, no issue. So we understand from the next table, this s2 will not be staying back here. This will be kicked out, and x2 this variable will come and join this group from the next table onwards, right? Okay, for the next table this will happen. Now this is our row, which is a leaving pivot row, and this is our column, pivot column. These two rows and columns are intersecting at the point called pivot element. This is the leading element for this matrix now. Leading element, right? Leading element, pivot, key element, you can call it this element in different names. This element lies at the intersection of the pivot row and pivot column. So this element is our leading element for the entire matrix. Now we consider it. Now the work of reduction starts now. What we have done in the case of reduction, if there is a leading element, this leading element should be converted into 1, and other elements in the column should be 0. That's the process of reduction, isn't it? So we are going to do the reduction again for this matrix. Now we are going to take only this matrix. Check this one. 1, 2, 3. First row has 5 elements, second row has 5 elements, third row has. So this is a matrix of 3 rows and 5 columns, isn't it? So let us take this matrix and use the reduction method to convert this leading element 3 into 1 and other elements in this column, this 1 and this negative into 0. So we'll go to the next page, right? Let me take the table along. First row 8, 2, 1, 1, 0. Second row 12, 2, 3, 0, 1. Third row 0, negative 1, negative 2, 0, 0. Okay, this is the given matrix for us. Now this is 3 by 5 matrix. Our aim is to make this element to 1 and other elements in the column into zeros. Clear? So this element, we are writing a new formula for row 2. Row 2 will be row 2 divided by 3. Just divide it by 3, you will get it reduced. No change in the row number 1. Change occurs in row number 2 divided by 3. This is 4, 2 over 3, 1, 0, 1 over 3. No change in third row, 0, negative 1, negative 2, 0, 0. Fine. Let's do it for the next table, next matrix. In this next matrix, so the purpose of reduction is converting the leading element to 1. That's done here. Now leading element is 1. And other elements in the column should be 0. So write formula for that one. What is the formula for row 1? Use row 1. And leading element falls in the second row, right? So row 1 minus, obviously, row 1 minus row 2 will give you second row. Row 1. So let's use this formula to write a row 1. Row 1 minus row 2. 8 minus 4, which is 4. 2 minus 2 minus 2 minus 2 by 3. What is it? 2 minus 2 by 3. 6 minus 2. 4 over 3, isn't it? 4 over 3. 1 minus 1, 0. See, this element in the leading column will be 0. Next, 1 minus 0, 1. 0 minus 1 by 3. 0 minus 1 by 3 minus 1 over 3. So first row is done. There is no change in the second row, which is 4, 2 over 3, 1, 0, 1 over 3. Write a formula for row 3 now. Row 3 starts with row 3 minus C. Row 3 has minus 2, so we add 2. We use positive 2 row 2. Row 2 is the leading column, leading element row, isn't it? So row 3 plus 2 times row 2. This is the formula for row 3. Row 3, what is it? 0 plus 2 times 4, it is 8. Minus, here row 3 is minus 1 plus 2 times this element, 4 over 3. Minus 3 plus 4, 1 over 3. Isn't it? And finally, no, this element will be 0 because minus 2 plus 2 times 1 is 0, isn't it? 0 plus 0, this is also 0. Finally, this one, 0 plus 2 times 0, this is 2 over 3. So, we have done the reduction in this column. The leading element becomes 1, other element the column becomes 0. That's it. Now we will fill the same element, the same table again back. We call it second table. Now we write second simplex table. The same, first basic variable, right hand side resources, x1, x2, s1, s2, 4 columns, isn't it? 4 other variables, so there are 6 columns. Title. Now basic variable is, see, go back, there were 2 basic variables in the first table, s1, s2. Now s2 will be replaced by x2, isn't it? So come back here, s1, x2. Now this is z downwards, isn't it? Let's fill the final matrix here as it is. No change. So it should be a 3 by 5 matrix, should be 1, 2, 3. Check, you can check 1, 2, 3, 4, 5. And see, you can fill the 3 by matrix here. For the first row in the first question, 4, we will finish it. 4 over 3, 0, 1, negative 1 over 3. Next is this row, second, 4, 2 over 3, 1, 0, 1 over 3. The final table, 8, 3, 0, 0, 2 over 3. Now all this called indicators. All indicators are positive. Here all are greater than or equal to 0. Therefore the optimum, we are looking for optimum, maximum is or minimum, optimum solution attained. What is the solution? How do you get the solution? The solution is from the first 2 columns. See, original variable is x2, s1 is dummy variable. We don't have x1 here, only x2. So x2 is 4, x1 is 0, x1 is not available in the basis, right? So x1 is 0, x2 is 4 is taken from here, x2 is 4, s1 we don't want, s1 is dummy variable, x1 is not available. So x1 is 0, x2 is 4, we don't want s1, s2. The z value is here, z maximum. So z maximum is equal to 8. Everything, all the solutions values have been taken from the first 2 columns. See, z is 8 here, x2 is 4, there is no x1 which is our main variable. So x1 is 0, x2 is 4. When you substitute this x1, x2 values in the original function, you will find here x1 is 0, x2 is 4. So 2 into 4, the answer is 8. So the maximum value of z is 8. So the problem ends when all the indicators in the z row are positive or non-negative. That's the end of this problem. Let's take one more example to understand this concept, right? Your syllabus involves only maximize problems. But in linear programming there are different varieties, minimization, and when there are greater than or equality, bounded solution, there are different varieties, but our syllabus deals with simple LPPs to maximize. Maximize z is equal to 8x1 plus 2x2 subject to the conditions. Let me check one more time. Okay, subject to the constraints x1 minus x2 less than or equal to 1, x1 plus 2x2 less than or equal to 8, x1 plus x2 less than or equal to 5, and finally x1 comma x2 greater than. This is non-negative restriction. This is the given LPP. Now let us start the solution. The first step we need to do is writing in standard form. First step. So objective function maximize z will be 8x1 2x2. There are three constraints, 1 2 3. For every constraint we are going to add a variable. So 0s1 0s2 0s3. There are three constraints, so three dummy variables, d3 slack variables, right? And write them here. So this is x1 minus x2, x1 minus x2 plus s1 0. This is first constraint. x1 plus 2x2 plus s2 is equal to 0. This is second constraint. Third, x1 plus x2 plus s3 is equal to 0. This is the third constraint. And finally, non-negative restrictions x1 x2 s1 s2 s3, all there are 5 variables. All variables should be greater than or equal to 0. So we have completed the standard form. Now using these values we complete the table, and then in the last row we will write the z in opposite sign, isn't it? Let's do it. First simplex table. First simplex table, isn't it? Okay. What is it? First column is for basic variable. Our basic variables are s1 s2 s3. Initially the dummy variables are basic variables. Next, right hand side values. The right hand side in the equation were 1 8 and 5. Now fill the columns of x1 x2, only two variables, so s1 s2 s3. What is the x1 column? Go back here. This is 1 1 1. All the elements are 1, so 1 1 1. What are the elements of the x2 column? This is negative 1 2 2, negative 1 2 1. This is 1, isn't it? Okay, negative 1 2 1. And obviously for this place you can write the identity matrix 1 0 0 0 1 0 0 0 1 identity matrix. If you go back and check the coefficients, it will be looking like in the first row, first equation there will be s1 no s2 s3. In the second constraint there is s2 but there is no s1 s3. The third constraint there is only s3, so s you will get identity matrix, isn't it? This is for title. And we may find ratio depending upon the entering variable. Okay, these two are our solution columns, basic variables and solution. We write z here 0 here and fill the last row by z. Where is z? Go back to the objective function. 8x1 2x2 0 0 0. 8 and 2 in negative sign, negative 8 negative 2 0 0. So we write the coefficients of the objective function in negative sign. Now the first step suggests use identify the this indicator z rows elements are called indicators. We repeat the process until we get all the values of z row are non-negative. Here the most negative is negative 8. So the VIP here is x1. He is the entering variable. Somewhere he is going to enter. Where? Which one of the variable is going out? S1, S2, S3 we will try. So this column is important for us. This is called the pivot column, right? Now let's find the row which is moving out. Ratio is r divided by, now in the previous problem it was x2, isn't it? But here it is x1. So we will write the formula as r over x1, and the elements of x1 should be greater than or equal greater than 0, strictly greater than 0, isn't it? The denominator should not be 0, and negative, for negative values, if there is any negative value in this pivot column, we will not find a r. So first element r is 1 and divided by 1 over 1, the answer is 1. 8 over 1, it is 8. 5 over 1, it is 5. So minimum value of the ratio is this one, the minimum ratio. This will give you the variable s1 is moving, so x1 replaces s1 in the next table. So this is the row which is called pivot row, the leaving variable column. This is entering variable, x1 is entering variable column, this is leaving variable row, this is leaving variable row, isn't it? So these two are intersecting at this point, so your pivot element is already 1. Pivot element is already 1, so no need to convert into 1. But the next condition is other elements in the column should be 0. That is the method of reduction we are using, isn't it? So let's write this matrix separately and then use the reduction method again. Let's collect this matrix again and then use our reduction, and then rewrite the next table, check whether all the elements in the z row finally, the final row is positive or not. Fine. Let's write the matrix. 1 1 negative 1 1 0 0, 8 1 2 0 1 0. Big matrices. 5 1 1 0 0 1 0 negative 8 negative 2 0 0 0. See, this is 4 rows and 6 columns matrix. Size is 4 by 6, very big one. Okay? Here, this is your x1 column, and your aim is to find the leading element is this one in the previous problem, check. So this is the leading element 1. The leading element is already 1, so convert the other elements in the column into 0. All the 3 elements should be converted into 0. So we are going to write formulas for this one. No change in R1, but change occurs in R2. R2 is R2 minus R1. Obviously, R1 is the leading element column, leading element row. R2 minus R1. What is for R3? R3 again, R3 minus R1. R3 minus R1. R1 if you are writing, we want the formula for R3, we start with R3. And R1 is the row that has the leading element 1, isn't it? That's why. And what is the formula for R4, row 4? Row 4, start with row 4, use row 1, but this is negative 8, so the coefficient should be multiplied there, so it will be positive 8 times R1. This is the formula to write all the 3 rows. Use this formula again, you know the reduction method, so I just write the answer here. 1 1 negative 1 1 0 0, no change the first row. Second row will be 7 0 3 negative 1 1 0. Third row will be 4 0 2 negative 1 0 1. Last row will be 8 0 minus 10 8 0 0. See, this is the reduced. Actually, we have reduced only this column. We got a leading element here, and other elements the column are 0. So we got this matrix. We are going to fill these elements the simplest matrix. And you see in the last row there is a negative. So we should repeat the procedure. So second simplex table. Let's write again B R x1 x2 s1 s2 s3. There may be a ratio we are finding if there is a leaving variable, right? The table final variable. See, go back here, we identified s1 will be replaced by x1. That's it, no other changes in the column. So x1, s1 and this is s2 and s3. This column, just fill the table here. This is it. Fill the table here. 1, 1. The matrix is filled here. 1, 0, 0. 7, 0, 3 minus 1, 1, 0. This is 4, 0, 2, negative 1, 0, 1. The last row is 8, 0, negative 10, 0, 0, 1. So this is the table. This is the solution title, isn't it? And you will find here the solution in B and R. This is our simplex table. See, there is a negative. Most negative here appears. Most negative appears here. So again there is a negative. Most negative. So this is the new entering variable. We have to repeat the process. New entering variable. So this is our pivot column now, and here there is a negative. So in this row we will not find ratio because there should not be negative. So what is the formula for ratio? Ratio is R. R is this column, and R divided by x2 here, x2. But x2 element should be positive, greater than 0. So here for the first row we will not find it. Leave it because there is a negative entry here. So second is 7 over 3. 7 over 3, something around 2.33. Now 4 over 2. 4 over 2 is 2. So the minimum most value is 2, and therefore S3 will be forced to move out. This will be the leaving variable row, pivot row. So the pivot element, the leading element is this one, 2. Okay, so x2 will come and join, replace s3 here. x2 will come and kick the s3 out. The next final table, right? This will happen. Again we have to start the reduction process. Convert the 2 into this element, leading element, into 1, other element in the column into 0. That's the process. We are going to take this matrix and use reduction method again. Let's take the matrix. Remember this row, we are going to write it again. So 1, 1, negative 1, 1, double 0, 7, 0, 3, minus 1, 1, 0, 4, 0, 2, minus 1, 0, 1, 8, 0, minus 10, 8, 0, 0. And now this is our leading element 2. The 2 should be converted into 1, and other elements in the column should be 0. That's our aim, isn't it? That's our aim. So write the formula for this one. What is it? First convert R3, the row 3. Row 3 divided by 2. What do you get? This is the new matrix. No change in row 1. No change in row 2. 7, 0, 3, minus 1, 1, 0. Change occurs in row 3. Row 3 will be divided by 2. So it is 2, 0, 1, minus 1 by 2, 0, 1 by 2. The last row has no change. 8, 0, minus 10, 8, 0, 0. Now we got this leading element as 1. Convert the other elements in the same column into 0. So write formulas for that one. So we will write the formulas here in the next table. So for understanding, write down. We need to change row 1. What is the formula for row 1? Row 1 formula, start with the row 1 and use the row second row, because in the second row we have leading element. So row 1 is negative 1. So this is R1 plus R3. For R2, what is the formula? Can you write yourself? R3, R2 starts from R2, and we should use R3, and this is positive 3, so we use here negative 3. That's positive 3 here. So what is the formula for R4, row 4? No change in row 3. It is negative 10 here. So you start from R4 Negative 10 you will write positive 10 and again R3. These are the three formulas that will convert the other column elements into zeros. So again rewrite these formulas here in this row, the matrix. So row 1 is row 1 plus row 3. Row 2 is row 2 minus 3 row 3. Row 4 is row 4 plus 10 row 3. When you apply all these operations the previous matrix, you get this new matrix. Try yourself. I'm just writing the answer. 3 1 0 1 over 2 0 1 over 2 1 0 0 1 over 2 1 negative 3 over 2 0 1 negative 1 over 2 0 1 over 2. This is 8 0 0 3 0 5. In the final matrix, all the elements in the last row, you see, all are positive, not negative, 0 or above. We are going to fill this matrix in the final simplest table. The final simplest table. Why this is final? Because there is no negative entry in the last row. So this is basic variable column. This is right side elements and x1, x2, s1, s2, s3. Let's fill this matrix as it is. So here basic variable we know. Go back. This s3 will be replaced by x2. So x1, s2 will remain. S3 will be replaced by x2. So x1, s2, x2. And now this is z. Just fill the table matrix here. 3 1 0 1 over 2 0 1 over 2 1 0 0 1 over 2 0 negative 3 over 2 2 0 1 negative 1 over 2 0 1 over 2. That's it. To find this, actually this is 28, not 8. You will solve and get 28. Check this one. R4 row 4 plus 10 times row 3. Go back. Row 4 is 8 plus 10 times row 3. 10 times row 3 is 2 into 10 into 2. So 20 into 28. This element is 28. Okay, right? So this is 28 0 0 3 0 5. Now when you finish the table, this is 20, this is solution column, isn't it? And this z is here. No more procedure, because see, you can stop here. All this z, because see, all indicators, all z are greater than or equal to 0. Therefore we get optimum solution. What is the optimum solution? It can be taken from here. X1 is 3, x2 is 2. Only two original variables, others are dummy variables. So x1 is 3, x2 is 2. When you use these in the objective function, z maximum is 28. That's the end. You can use these values of x1 and x2 in the original function. Where is this one? Check here. X1 is 3 times 8 24 plus this x2 is 2 into 2 for 28. That's what we got in the end. That's it. That's what we get here as 28. To the end of this problem. Thank you very much.